Greetings, ACT Specialist Commander King here with yet another example to help you prepare for this Taking Back Saturn mission. I know, excuse me. I know we're excited for this. Alright, so let's see what we've got here. We need to make hydrogen gas, and hydrogen gas can be very useful for a number of reasons. We've seen that hydrogen gas can, cause a popping sound, so maybe we want to use it for a combustion reaction to create some energy for this mission. A lot of uses for hydrogen gas. But it looks like we have 65 grams of zinc, so it looks like we got 65 grams of zinc, and we have 65 grams of HCl. So it looks like we're limited in what we have. These are our reactants, right? And this is already balanced, I think. Let's see, 2 H's, 2 Cl's, 2 Cl's, 1 zinc. All right, cool. And we want to know how much H2 we can produce in this reaction in terms of grams. So we want to know how many grams of this stuff can we produce. Okay, well, we're given two things. So this looks to me like a limiting reagent type problem or a limiting reactant type problem because we have two amounts and we're not sure which one's going to run out first, right? Like, it's possible that these mix 1 to 1 and we just left with none of anything, but more likely one of these is going to run out first. So we need to figure out which one runs out first. And to do that, conceptually, what I'm thinking is, okay, well, which one is going to make more moles of H2? Or sorry, which one's going to make less moles of H2? Because whichever one makes fewer moles, I guess fewer, right? Fewer moles, I can count moles, okay. Fewer moles of H2 is going to be the one that's the limiting reactant, and that's going to limit how much I can produce. So for example, like, you could have one crust and a billion pepperoni slices, but you could still only make one pizza because you have that one crust. Same thing, maybe we have a limited number of zinc and a ton of HCl, and so the zinc's going to limit how much HCl we can produce. So this is similar to what we've been doing. We want to think grams. Well, I can't convert to the moles of H2 unless I first convert to the moles of Zn and moles of HCl, because then I can use my handy-dandy molar ratios to go from there. So it looks like I want to get to the moles of zinc and the moles of HCl, and then from there, right, I can use my molar ratio and figure out which one is the limiting one. Which one will produce less? So let's do that first. I'm going to call this 1. I'm going to call this 2. Okay. So the first thing I need to do in both of these is actually I need to convert to the number of moles. So I'm going to start with the zinc. So let's start with the zinc. The zinc, I know I have 65 grams of zinc. Okay. And I know I need to get to the moles of zinc. So to go from grams to moles, I'm thinking I got to get from grams of zinc to the moles of zinc. Oh, that seems perfect. I probably need the periodic table. So my conversion is going to be on the periodic table. And let's see if I can pull one up. Right here. Okay, so zinc, 65.39, 65.39. And remember, it tells me the grams that are in 1 mole. All right. So let's set that up. I know 65 grams, 65.39 grams of zinc per 1 mole of zinc. And so that looks like it's going to give me roughly 1, but if we want to be super duper precise, 0.99 moles of zinc. Okay, and I'm looking here, I see, okay, no, if I have 1 mole of zinc, right, if I had 1 mole of zinc, I would produce 1 mole of H2. So if I have 0.99 moles of zinc, I would have 0.99 moles of H2. Like, just like if I have 3 moles of zinc, I would have 3 moles of H2. Well, I have 0.99, so I'm going to have 0.99. And if you want that conversion, I know that I'm going from moles of zinc to moles of H2. And in 1 mole of zinc, I produce 1 mole of H2. Remember, those coefficients not being there, meaning it's just 1 to 1 ratio. So, of course, 0.99 moles of H2. So what have I just figured out? I figured out with 65 grams of zinc, I can make 0.99 moles of H2. Cool. Well, let's look at our, what are we looking at now? We're looking at our HCl. Well, we know we have some amount of HCl, and we want to go to the moles of HCl. And I can also then, from the moles of HCl, go to the moles of H2. All right, so what's going on here? I've got 65 grams. Let me use a different color to differentiate. So I'm going to use maroon here, I guess. All right, so I've got this plan here now. Let's see how many moles of H2 that this 65 grams of HCl can make. Well, I know I've got 65 grams of HCl. I know I want to cancel the grams of HCl to go to the moles of HCl. So let's see. I've got H, which is about 1.01, and Cl, which is 35.45. So just a quick calculation, that gives me 36.46 grams per 1 mole of HCl. That's going to give me, let's see, 65 divided by that. Oh no, what happened? Alright, sorry about that. A little confusion there. That gives me 1.78 moles of HCl. Boom, right here. Technically 1.8 with sig figs, but I know this is just an intermediary step, so I know I have 1.78 moles of HCl. Let's see, for every 2 moles of HCl I have, I make 1 mole of H2, so I'm thinking, okay, like, this number here, the moles of H2 is always half that, right? So I know I'm going to multiply it by 1/2, you know, because the number of H2 produced is always half the HCl. So if I divide it by 2 or multiply by 1/2, I would get 0.89 moles. And if you like that calculation out, well, I know I need to cancel the moles of HCl. I know I'm going to the moles of H2, and I know that for every 2 moles of HCl I use, I create only 1 mole of H2, and so that's going to be 0.89 moles of H2. Okay, so which one produces less? Is it the 65 grams of zinc, which produces 0.99, or is it the 65 grams of HCl, which produces 0.89? Well, it looks like this number is less, right? So it looks like the HCl is only going to produce 0.89 moles of H2. And so that's actually going to be the least amount of produce. So I might be thinking, I'm done! 0.89 moles of H2. The 65 grams of HCl is limiting my reaction, but wait a second. They actually want the grams of hydrogen gases I've circled here. And that's one final calculation to go from grams, or from moles of H2 to grams. What conversion do I use? From moles to grams. Oh, right, the periodic table. And I know on the periodic table, in 1 mole of H2, I have 2 H's. So H is 1.01, so 2 of those is 2.02 grams of H2. And so I just need to set up my conversion correctly. I'm running out of space a little bit here. I'm going to borrow the next page. Don't worry about the things at the top. I know I've got 0.89 moles of H2. I'm converting to the grams of H2. And so I know in 1 mole of H2, let's look back. Oh, that's right, I've got 2.02 grams in 1 mole of H2. So, okay, I can multiply that out, and that's going to give me about 1.79, but 2 sig figs, 1.8 grams of H2. So that's how much grams of H2 I can actually produce, 1.8 grams of H2. Okay. And so just to reflect a little bit and to summarize, I know with 65 grams of zinc, I can produce 0.99 moles of H2. With 65 grams of HCl, I can produce 0.89. So basically, what will happen in this reaction is the HCl and the zinc will mix until they produce 0.89 moles of H2, but then there's going to be no more HCl left over for the zinc to react with, so the reaction will stop, and I can only collect 1.8 grams of H2. So again, this is a limiting reagent type of problem. The key sign is you're giving 2 reactants and asked to predict how much product is produced. Okay, fair enough. That's all for that. Hope that was helpful. King out.